Tanya, oh, Tanya, I responded to your question in the chat.
Okay, all right. So it's being recorded, which means that we're going to have a discussion which you can go back to, right? You can go back to and review many times at your own leisure. You can talk, you can review the discussion that you guys are having with other people chiming in and everything, and I'll just be a passive bystander. If you guys make any horribly wrong turns, okay? So if you turn to the wrong street when going from here to San Francisco, it's going to take you like 10 more minutes to get to San Francisco. I don't care, okay? I'm just going to sit down and keep watching, and okay, that guy's going to be delayed a little bit, right? But if you turn into into the opposing lane, right? You drive on the other side of 101, like in Great Britain, and the cars that are coming towards you, then I'll step in. I'll say, hey, get back on into your lane quickly, or you're going to get run over, or suffer a collision, right? So those are the only situations when I'm going to jump in and do some course correction. But otherwise, I want you guys to make a lot of mistakes, okay? Not fatal mistakes, because I think mistakes are, so if you learn something by making a mistake, it is 100 times easier for me to teach that to you than to describe the issue in great detail, right? I could go into painstaking detail and describe something to you and say, don't do that. But if you make a mistake and learn it, you'd learn it like that, right? So I think, and you'll remember that too. You'll remember that longer. So I really just want you to make a lot of mistakes while I'm there to steer you away from making fatal errors, okay? So you don't end up doing something horribly wrong. But I want to see you guys. And when it comes to coding time, right? When it comes to coding time, I think what we'll do is maybe the previous day or even during the day, if nobody has picked up something to code, that you can look at last quarter's lectures again, right? So when we're doing some online on-screen coding, when the modules, the corresponding modules for that week are about branching statements, we only code something up to do with branching statements, right? Or if calculating expressions, simple expressions, we only do a coding exercise on screen to do with, so which means that gradually as the quarter progresses and we learn more and more skills, right? Initially expressions, then branching statements, then looping, then arrays, and so on, right? What you're going to work on in class now will also gradually evolve, right? So towards the end of the quarter, you're probably together, all of you, implementing something really cool, which uses all of the features that you've learned during the 12 weeks, right? So expressions and clever ways of using, not clever, in programming, I always say it helps to not be clever. Well, that's a bad way to say it, because you have to be clever, but you have to be clever in the right ways, right? You can be clever in the wrong ways. And I think, what is being clever in the wrong ways? Being too clever for yourself. Okay, being too clever for yourself is being clever for the wrong way, in the wrong way. And what do I mean by that? Being too clever for yourself means that you came up with a really, really clever way to do something, and it gives you a phenomenal improvement, right? And then you're clever and do that, and you think that you're clever, and you don't need to really explain it to you or to someone else. And you say, well, I've coded it up, it's really fast. If someone doesn't understand how I do it, well, that's too bad. They're not good enough to understand my code. But I know it's really fast, so people will use it. But then after 5 years, you come back and look at your own code, and you've forgotten why it does what, and you've forgotten the logic yourself, and then you don't know how it does it. That means you're too clever for yourself, okay? Because you were clever, but you're not clever enough 5 years later. So that's what I mean.
I have a question on that.
Yeah, sure.
Isn't that what the comments are for?
Yeah, absolutely. The comments are there.
Describe that.
So yeah, exactly. Thank you.
I remember this from previous classes. That's why I always put comments in your code so you know what it does, right?
Yes, absolutely. So comments are good, but very soon you'll get to a place where where comments are not going to suffice. Your algorithm itself has to be self-documenting, and also you don't do some crazy ass things that give you a marginal win that is not worth it, right? I don't know if I can come up with specific situations right now. Maybe we will come across these as we code, but there will be situations where you can make a small improvement that will give you like 2 or 3 machine cycles, a gain, right? A win of, and people say, hey, cool, that's really cool, I'm going to do this. But then, that win really doesn't matter in the larger scope of things, right? Because by not doing that, maybe you'll come up with a much better improvement that gives you an order of magnitude improvement, right? So, or a big O improvement rather than, a linear improvement. So things like that, you'll find. And also the other thing to do with comments, and this is something you'll have to discover on your own, is that there is such a thing as too much commenting, right? And I think what happens is that when we start our coding during the early stages of our coding life, everything is really fascinating to us, right? We learn about branching statements and we say, wow, that is so cool, it happens, right? So lots of things are really cool and lots of things are really new. And so we end up commenting everything that we think is cool, and also the things that we didn't know like a few days ago, right? Oh, I just learned this and it's really cool. There's a risk I might forget that, so I'm going to comment that, right? So maybe a classic example, I've seen code in which people say I++, right? So incrementing I, incrementing the value of I, and previously they were only used to saying I equals I plus 1. Right, and they learned this new syntax in C++ that says I++ is the same as I equals I plus 1, and so they put a comment there saying incrementing I, right? Incrementing I is a comment for I++, and for a professional programmer, that really is more of a hindrance to see that comment, right? Because extra characters, extra material that I have to absorb and understand, and more bytes there visually, more ink on the page. Whereas I++ to a programmer knows exactly what it says, right? So they know. So there is such a thing as too much commenting, which you will eventually get the hang of. So I think the holy grail really is figuring out, and it's different for different people, but they all converge to pretty much the same spot, I think, is figuring out the place where commenting ends and cleverness begins, and also the place where you get to be too clever for yourself. And I don't know how you can find out, right? You got that's only through experience. You find out over a long period of time. Well, that place I was too clever 5 years ago. That place I was too clever 2 years ago, right? So essentially, every time you program, you're programming to save yourself time, right? Programming really, computer science. What is computer science? Computer science is an art that allows humans to save time, right? So that we'll have more time to enjoy life, right? Because you think about it, if we were to do all the tasks that computers do today by manually, right? We won't have time to do anything else, right? If we just said no more machines, no computers from now on, we'll be working 24 hours a day, right? The whole idea of machinery automation really is so that all the grunt work can be taken away from us, and then we'll have more time to live like human beings, not like machines. And so if you do something that buys you 10 seconds of time today in your life, but 5 years later, it takes away 10 hours of your time trying to understand what you did 5 years ago, right? Then what that means is that you have basically bought 5 seconds of your life today. You've bought 5 seconds of your life today at the cost of 10 hours of your life 5 years from now. Right? So 5 years from now, imagine how much more valuable your own time will be. Right now, you're a student, right? Most of you, you're students, and your time is, I don't know, I don't say it's not valuable at all, but I suspect, right? This is the case, that your time 5 years from now or 10 years from now, when you have discovered, right now, I think it's a fair game, right? It's a reason, when I can say with a reasonable chance, that right now you have not yet discovered 50%, at least 50% of the greatest pleasures in life, right? Throw in everything, throw in sex and all, the greatest food and feasts, everything you've had in your life, throw in everything. Even then, I think it's a safe assumption to say that over 50% of the greatest things you have to enjoy in life are still there. Still there. You haven't yet experienced them. So maybe in 10 years from now, I would say the chances is much lower, right? Maybe there's a 90% chance that you've seen the greatest things that life has to offer, right? So, and I think this is my hypothesis, that 10 hours of your time, that time when you see the entire menu in front of you, is worth more than 5 seconds of your time right now as a student, right? Because, you know, if when I was like very, very young and I got 2 hours more time, what would I do? You know, I'd say, oh, you know, 10 years, I got 2 more hours. I'm going to go and play some Fortnite, right? Or do some really cool things. And then I forget about it, right? I don't remember the games that I played 5 years ago, right? Even though I might have had some incredible victories, right? So I captured all the flags, like Elizabeth said, right? So I wouldn't remember that 5 years ago, now 5 years later. So, and I think that, so when you code, try and code in a way which will try and code in a way that will save you time, save your future self time, right? So save 10 years from now, say 10 years from now, it will save you time, assuming that your code is so good that it survives the 10 years, right? Because many times people write code that's not even going to survive for 50 years, right? Or 10 years, or even 10 years, right? 10 days, right? They write code and the code is really horrible, right? And useless, and maybe it's fun for 10 seconds and after that it's dead, right? Nobody cares about that code. Even you don't care about your own code. So there's lots of code like that. And but I have seen programmers waste a great deal of time and energy trying to optimize code to a great deal with a great amount of effort, which the code itself I can see is not going to last much longer, right? So they're optimizing for 5 years down the line. When 5 years down the line, this program is going to be history, right? And I've seen a lot of people like that. In fact, once upon a time, I knew a bookie. Well, I'm not a gambler, but I knew someone who used to be working as a bookie in the races, and then he said he knew another bookie who was doing something illegal, right? And he said that other guy made a lot of money because he would, when people come in to bet on horses, this guy somehow knows, or he said he knows which horses are going to win and which horses are going to lose, right? And so when someone comes in and bets on a losing horse, he would give them a fake ticket and basically pocket the money. Because he knows that horse is never going to win, so that money is as good as lost for that person. He's going to pocket the money. But what happens if that horse actually won? This guy is ruined, right? If the horse actually won and the ticket is not on the books, and they're going to come and ask, right? That guy won. You got to pay him like $5 million, and that money has to come out of this guy's pocket now, right? So he was playing a very risky game there, but like that. But what was he trying to do? He was trying to save money from something that's never going to happen. So he thought that horse is never going to win. And someone's betting like, $100 on the horse. So I'll just take the $100 and, buy myself something nice, right? And that was really risky. And likewise, so when you code, you try and minimize your work down the line. If you think that program is not going to survive, don't bet your time and effort on that program, right? Do something on that to just get you past that learning hurdle. And then that program is history, right? So if you put that in the right perspective, I think it'll be nice. Okay, so that that is a bit of daily ramble on. So now I think I will, number one, Elizabeth said, always be thinking ahead, make preparations, And by the way, please excuse me if I'm not responding to your chat messages, right? Because when, obviously you should be chatting and talking amongst each other, but I will look at the chat window from time to time, but it's hard for me to look at the screen and talk and also follow the chat at the same time, but I will look at the chat from time to time. All right, now go ahead and verbally, not in the chat, okay, verbally, and take the screen, right? One of you can take the screen, pick up some example, maybe even converting your names, right? Maybe maybe some decimal conversion, binary conversion, hex conversion, or two's complement, right? Two's complement, floating point. Those are the places where most of you get stuck, right? In past experience, right? So two's complement, how to convert from two's complement. What is two's complement? What's a negative number? What are different ways in which you can represent negative numbers, and so on and so forth. You may think that data representation issues, they don't come back later. It's just the first 2 weeks, and in fact, in 2A, they don't really come back explicitly, like no data representation in final exam, right? Or even in the midterm after the data representation quiz. But you will see the data representation issues are so core to the whole field of computer science that even later on, after you finish 2C, these data representation issues will be totally useful to you. As an example of which, this Curiouser and Curiouser contest that I posted, right? I think it was last month. I posted a contest last month, and I gave prizes. All the 3 students who won the contest, right? The first 3 places, I think $150 to $100. They all exploited data representational issues to win the prize, because the guys who didn't exploit data representation, they were nowhere near the score of the people that exploited data representation. So you can imagine when you start working for these big companies, and you can look at algorithms they're using, and you can make fundamental improvements to their algorithms, right? So maybe you go to Google or Microsoft, and maybe they're using an algorithm that was written by maybe not really the top of the line in software programmer, some ordinary programmer who squeaked in, right? When a company grows beyond 100 people, I think it's beyond 100 people, right? So maybe many people think it has to be beyond 1,000 people or 10,000 people, 50,000 people. No, I think this is where I've seen it happen. Maybe I'm wrong, but I've seen this happen up to 100 people. Until we recruit 100 people, I think we can have a reasonable hold on the quality of engineers we hire, right? On the quality, and I think this is where everybody struggles with that. I think Steve Jobs, I think famously, I think he also struggled with that, and I think he said he eventually arrived upon this, which I think everybody does also, right? The only way, right? It's impossible. It's impossible when your company starts growing beyond 100 people. I think 100 is that sweet number, somewhere around there anyway, right? Beyond that. It gets impossible to make sure that all of your employees, all your engineers are A engineers, A class, right? A plus programmers and A plus engineers. It's impossible, right? So mediocre people are going to squeak in, and then at that point, the company strategy does not will pivot and say, well, we're going to have mediocre engineers, no matter, even if we are the best software company, in the whole damn world. We're going to have mediocre engineers because we're more than 100 people, right? And so then resource utilization, human HR, right, takes a different turn. It takes a different turn, saying, well, there are going to be mediocre, so we are going to have jobs that are not, they're going to be, because our company is so big, they're going to be programming tasks that are not like super critical, right? So meaning that they can break and then they can be fixed, or there's more quality control. There's lots of things that need to get done, routine grunt work that needs to get done, that I don't want to waste my A programmers for, right? The star programmers, the 100 people that I know are really good, I don't want them to be doing all these routine stuff. So they will be my core executive group, right? I confer with them, and the really cool, amazing ideas emerge from there. But at the same time, there's all the routine work that needs to be done. I'll get mediocre, not horrible programmers. You can't be a horrible programmer and get into the top companies, right? But you can still be a mediocre programmer and get into a top company. So if you go to a place like Microsoft, Google, anywhere of these places, right? So you will find some mediocre programmers, and maybe you come across some code that was written by a mediocre programmer, and it's still living in the code base. You go into the version control system and you see code that's mediocre, right? And in fact, you can see Chrome, right? You use Chrome. When Chrome came out first, it was like blindingly fast and thin and lean and just did a lot of things really nicely. But now I'm actually a little concerned to leave Chrome running overnight. Well, not that much, but I'm concerned to visit certain websites that use Chrome, because I know that Chrome does not have the right JavaScript handling of a certain code that people maliciously inject maybe into some pages. So when I go to some pages and they have ads running, or maybe it's even Google's own code, right? I see Chrome basically chew up 99% of my battery, just one page out there. Yeah, and my fan kicks in, right? And then I have to go and kill Chrome. And you wouldn't expect that from a top company, right? One of the top companies out there, but it does happen. It does happen. And I don't take the trouble sometimes to file a bug report unless it's really, really annoying and keeping me from doing my own work, right? Especially since there's so many options, right? You try Mozilla and Firefox and Edge, and so there's so many different options. So
is that why you actually need to optimize your code? Because otherwise stuff like that can happen?
Well, I would say optimizing is also really risky, because optimizing has to be done really, really carefully. what I find is that many programmers will spend a great deal of time optimizing the wrong things. Again, maybe it's worth reiterating here because I go over this. I think almost every single quarter in CS2A, I go over this point. And I think it is a brilliant observation. It's a brilliant observation made by I don't know, right? I read it in as part of Don Knuth's writings. I don't know where he mentioned it. You know, I don't know where. Right? So there's so many places. He's got his fingerprints all over the bloody you know. Attributed it to Tony Hoare, or someone else, right? He said, premature optimization is the root of all evil. Okay, and it doesn't make a lot of sense to you right now. Maybe it makes sense, maybe it doesn't, but the profundity in that observation will slowly start sinking in, right? Maybe a microliter by microliter into your mind, so that after a couple of years, or maybe after 10 years, you'll see, well, I mean, what a magnificent, fantastic observation to make about programming, right? Only someone who has really soaked into the blood and genes of programming can actually make an observation like that, I think, right? So because what we find is that many programmers will say, well, you know, there's this big program, but there's you know, inefficiencies here. Oh, that's inefficient. I'm going to optimize all these places, and they spend a great deal of time optimizing this part and that part and that part. And these things are visible, right? You can see these places are inefficient, and but that is actually the wrong thing to do. And that's you know, the Knuth's observation. So the right way to profile a program is to first find out where the computer, the CPU, is spending its time, right? So maybe,
well, that's what I was talking about. Yeah, like that's what I was thinking. You know, the right way is to maybe first, you know, check what resources the program is using first, right?
Yeah,
where,
yeah, exactly.
Then after that, you can find which parts you should optimize, right?
Absolutely. In fact, CAD, there is a tool that lets you do that. Did you know there is a tool that lets you do that? Chad?
Yes, resource modder.
Is it in the like the Chrome store, like the Play Store, like
No,
as
I'm
a
talking about
plugin, or?
programming. No, in general programming itself.
Oh, general. I thought we were still working on the
I think it's called
example.
a profiler,
Yeah. No, in
right?
programming, there is a tool which we've been using for a long time, decades, right? Which lets you do exactly what Chad wanted, which is to take your program and look at the program and tell you, in this program, these 7 lines of code, this million line code base, right? There's a million lines in this program, but there's 7 lines of this code, seven of the million lines, which is hidden away, which you don't even see, right? So you look at the million line code base, and you can see glaring inefficiencies here. So you need to optimize these things. You think in your head, but you run this tool, and this tool will tell you, well, you see all these inefficiencies out there? Perfectly fine. You can leave them all, right? Doesn't matter, because what you don't see is 7 lines, and the 7 lines are hidden away in this procedure that's called by another procedure that's called by another procedure. Deep inside your code base is 7 lines. You see the 7 lines? Those 7 lines are what you need to optimize, not all these other places where you see these inefficiencies that you never even saw, but that you need to optimize, because those 7 lines get called like 3 billion times. These places that you can see are inefficient will get called like 4 times, 7 times, 2 times, right? So your CPU spends a great deal of time in those 7 lines, not spending a great deal of time here. So optimize that and not here. And you will not know that, right? You won't know that's where you need to optimize until you run this tool, which is called a profiler. Okay, this tool.
That I think I remember. It's called a profiler. I've seen it in Unity.
Yeah, in fact, there is a profiler built into Xcode, most of these things, even on the command line. I think I think it's -P, right? There's an option called -P. When you say -P, what it does is that it takes your code and instruments it, right? It puts in secret code inside of your code to let the profiler measure when your functions are being entered, when they're being exited, what time they're being entered, what time they're being exited. So the profiler actually measures every single line of your code. It measures how often it got executed and how many seconds, how many milliseconds right? So imagine, right? So after you run the profiler, you'll know exactly where you need to optimize, and then you can go to this company and say, people are working on optimizing these, totally useless pieces of code out there, and you run the profiler and say, I went in and optimized that little thing, okay? And then your little optimization gives the company $1 billion win immediately, right? Because you change something that nobody can see. And
so I know some. So I have a quick question. So what's a recommend compiler?
What is a what?
What compiler do you recommend for this class?
Oh, I don't care. You use anything as long as it's
Visual C++ works.
Yeah, just G++, C++, C lang.
Microsoft Visual C++. I think they have a profiler, right?
Yeah, I think I think that's why I love teaching C++, because it's such an old language. The standard is now settled enough that it's got enough inertia. It's got enough mass. It's got enough mass. The C++, the language standard has got enough mass that to change the standard takes a great deal of effort, right? So if you have a mountain of mass, it's really hard to push it, right? But if you only have a little pebble, you can push it easily. So C++ is a mountain, and if someone wants to change it, it's very hard to introduce changes into the language itself. Therefore, it doesn't matter which compiler you use, right? So all of the compilers have to be compatible with the latest published standard. So it doesn't matter which one you use, they're all fine. If you're asking about IDEs, right, the development environments, in fact, you'll find that the IDEs will run your compiler in the background, right? Without you knowing, the IDEs will run the compiler. And I think what happens is that, the IDEs come in various flavors, and some of them are cooler. And also, I think with IDEs, you can say that each IDE has a particular style and a look and feel that some people may like and some people may not like. So with IDEs, you can make an argument saying, I like VS Code, I like Xcode, right? For my style of working, Eclipse works better. So I don't know if you can make that statement about compilers. Does that make sense? Okay, well, Elizabeth said, I believe so. So I think Elizabeth's speaking for all of you. Was that right? Everybody take off.
I had a faintly separate question.
Sure. Is that Chad?
Joseph.
Oh, Chad is highlighted here. Wow. Yeah. Okay, go for it, Joe.
So I kind of picked this class C++ because it was available, but there's
Right.
a lot of other programming languages.
Uh-huh.
What would you say would be like the most worthwhile to learn? Would it be C++ or would it be something else?
What do you mean worthwhile? Well, if it's worthful, yeah.
I don't know. I don't know enough to answer that question.
Right. So because
what are you trying to make?
Yes.
That's your first question.
Thank you, Elizabeth.
Right. Nothing in particular at the moment. But okay. if I were to say, hey, I only want to learn one programming language,
I don't think you can.
Would you say?
If you're trying to go into a software field. Oh, Thomas says Python, though. I would agree. Python's pretty simplistic, pretty easy. If you're just trying to do basic stuff, go there. But I mean, if you're doing web development, you're going to need to learn, what is it, HTML, JavaScript, and something else. I'm forgetting.
A lot of these other languages, JavaScript, Java, Python, they're all written on C++. It's a very important language to learn, I don't really know it yet, but I do know JavaScript, from what I heard, these type languages and C++ is an important language to learn, and a lot of applications are built on C++. I don't think it really matters what language you learn, rather what because I mean, theoretically, you could make anything with any language, but some languages are just easier than others in terms of certain things. So.
Yeah, it depends on how much you really want to understand it too. I'm definitely a person first got into repairing computers, and I looked over at my laptop and I said, "What does that look like on the inside?" Ended up having to buy a new laptop because I fried it, not knowing that I should ground myself first. But like I I look at coding as like how much you want to understand, because if you just want to make a program, and I mean there's Unreal Engine that has things like their blueprint system and simpler languages like Python that people have modified and made add-ins on, and you can go for it with any language, but C++ and Java are some of the more complex ones, I would say. Correct me if I'm wrong, but I'm pretty sure that's, yeah, he's nodding. So yeah, it depends on the, you kind of jumped into the deep end of the pool on this one, Joe.
Well, I've taken other programming classes before. I'm not
Oh,
completely
okay.
in the deep end.
Okay. The middle
but
of the pool.
yeah.
Here, so if you guys want my 2 cents on this, I'm happy to, because this is a question that gets asked every single quarter.
Please.
Yeah, go for
So yeah, what I believe, what I think is, and in fact, there's an opportunity for at the end of this, right? So I think that for young programmers, right, that maybe you're not like kiddos, right? So I think who was it? I think was it someone who was sitting here, Ben, or who brought up his 5-year-old kid playing with Minecraft, right? So if you're a
that was
kid, who was it?
nephew, actually. Oh, that was me.
Yeah, okay, all right. So I think for them, something like Minecraft or Scratch, MIT made a language called Scratch, right? Really helps because you don't need to have to be extremely disciplined to use these languages, and it gets stuff done, and you can see things visually. So from that perspective, for someone who is at a 2A, CS2A level, I might say that JavaScript would be a really cool first language for the reason that it gives you a lot of immediate visual eye candy feedback. Right. So things that you do in JavaScript, there is the prospect that you can do something and immediately see some magic bells and whistles in front of you, which gives you a great deal of satisfaction immediately. Right. So and when you get and I think the advantage of that is that you can get the logic down first. Right? Getting the ability to think clearly, think logically like a computer. That's the most important thing. And Scratch and JavaScript and all these other things, untyped languages, even Python to some extent, right? So they all work in that direction by saying, well, we'll take care of all the painful details, like you won't see the red ink on your compiler page just because you got the wrong type and your character instead of integer, and extreme discipline, right? C++ requires a great deal of discipline, even to the level where you need some extra memory. You need to ask the computer for memory, use it, and then give it back to the computer and say, I'm done with it. If you don't give it back, your computer will get fatter and fatter because the system gives you memory and it's not taking it back, right? And you're holding onto the memory, you get fatter and fatter until such time you can't live in a computer and you'll die, right? So you need a great deal of discipline to be able to program well in C++. But and the flip side is also bad, because many things you do in C++, you don't even get to see a visual cool effect, right? Unless you're doing something in with OpenGL and graphics and things like that, you don't get visual feedback that is satisfying immediately. Well, you do, but not to the extent you get it in JavaScript. Right? JavaScript, you can do some really cool things and immediately see some fantastic things, happening right in front of your eyes. And that gives you a great deal of satisfaction immediately. Python says, okay, well, you can still do the logic, but you're not going to see all of the graphics, but you'll still see, ASCII output, but you won't be penalized for doing, marginally wrong things, like, wrong type variables, the interpreter takes care of these things. So I think there's this scale, and I think the younger you are, the language that promises more instantaneous feedback, right? Instantaneous gratification, not feedback, right? It's gratification. Is so as you get older and older, you're able to delay your gratification more and more, saying, I'm willing to do the hard work because what I'm going to get out of it later on is going to be even bigger, right? So when we get older and our mindset becomes like that, and we prepare our mind to receive much order of magnitude bigger gifts, right? You do something in C++, a big project, you may not see the result until you're done with 20,000 lines or 30,000 lines of coding, and then you run it and you see the result, right? So you have to have a great deal of deferment in your mind. But on the other hand, after you run 20,000 line program, the effect might be fantastic, right? Maybe that works and it gives you enough money to buy a lakeside home, right, in Tahoe or something like that. So the benefit will be bigger, but you have to defer that greater. But kids don't have that, right? So as you grow up, I think, so the younger you are, you have to pick a language on that scale, right? Pick something that gives you immediate gratification, like Scratch or something, right? Or Minecraft, when you're really, really young. And as you get older, try and defer. And when you get really old, like 2A or beyond, I think C++ is fantastic, because I think that every programmer, no matter what, right? Especially, how do I say this well, if it comes across in a non-nice way, just imagine that I don't mean it in a non-nice way. I mean it in yeah, okay. So people that have learned languages like Java and become professional programmers in Java before they learn something like C++, or even understand C++, they don't have to learn C++. I generally tend to be more reluctant in hiring, for example, right? Because Java, what's the best analogy? Right. If you had to hire two people, and one of them is really messy, right? They both get the job done, but one of them is messy and indisciplined, right? Because they've lived their entire life in a very wealthy home with 5 servants following them around, right? And they pick up their trash, they take care of all their little jobs for them. And they are a bad hire for you as a programmer, because they're not going to be disciplined programmers, right? Because things have been changed. So in Java, you don't have to be as disciplined as in C++. So you can allocate objects willy-nilly, right? And when you don't need the objects, you don't need to be disciplined enough to give it back to the operating system. The operating system will kick in, a garbage collector will come and pick it up for you. It's like a servant following you around, right? So you can be totally spoiled programming in a language like Java. And I have seen code written in Java in which, there's no memory leaks, but still objects were being created and destroyed. Large objects were being created and destroyed completely unnecessarily. And in C++, what a programmer might have done, or even in Java, right? A disciplined programmer in Java would have engineered it in such a way that the same object is being reused again and again, just the fields are being, swapped, filled. So that the operating system or your program does not have to suffer the overhead of destroying the object, creating another one, destroying the object, creating another. So that introduces a huge delay in your program. Whereas in C++, it's one object, and then the fields are being changed. Bam, 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 bam. It's really fast. And you can do the same thing in Java too. But someone who did not do C++, or someone who didn't have the right intuition, may do it the other way. And the program works, but it's still slow. And it's because it wasn't done in a disciplined way. They're taking advantage of the operating system. Say, hey, I don't have to. But if you try and do the same thing in C++, your program will die. Because if you allocate something and don't deallocate it, your program gets faster. And within a few iterations, your program will crash. And you say, I got to do it the right way. I got to do it the disciplined way, or my program is not even going to work. Whereas in Java, you can do it the indisciplined way, and your program will work, but in an inefficient way. I don't know if that makes sense, but so I think learning C++, or at least getting into the C++ bent of mind, will actually make you a better programmer, no matter what language you program in, right? Maybe you learn C++ and then become a Python programmer, right? Java programmer, or maybe some future language in which you don't even deal with lexical tokens, right? Maybe something like Scratch taken to the next level altogether, right? You basically program by rearranging concepts, right? You got this screen like Minority Report, right? And then there's these concepts that you just have to pull in and link, and then that's your program. Bam, right? Even then, a C++ way of thinking about the program, the problem to be solved, I think, will go a long way to improve the code that you create. Yeah, absolutely. Python is great because it's great, but you still need to do C++, obviously, or learn C++. Python, what happens, I think, is that a lot of the a lot of the processing that you may need to do in specialized areas, right? Like crunching huge matrices for machine learning and things like that. There are people that have done libraries in highly optimized hardcore C++, right? C++ with extreme optimization. These libraries for number crunching and graphics and everything have been done in C++, and then the APIs and the hooks, created in such a way that they integrate into Python. So even when you make a call in Python saying multiply these two matrices using NumPy or something like that, right? It will actually use C++ code internally, right? And so that will be, and that's another reason also when you use higher level languages to try and make use of libraries out there. When you know what needs to happen, use a library, because the library, especially old libraries, not libraries just sprung up like 2 years ago, right? Old libraries have been debugged a lot extensively. And with that said, a bunch of my old students, right, previous students from last quarter, I think the last quarter and the quarter before, they got together, I think about 4 students, and they want to develop a really cool web app, right? And this web app were actually originated in last quarter's, in a lecture during last quarter, right? Last quarter CS2A lecture, we were talking about a really cool little web app, right? So it's a fun game. It's a game that also introduces sorting techniques, right? Without even telling people, right? They'll know what sorting does. And it's a really cool little game with graphics and sound and everything. And they're doing it in JavaScript and HTML. And with homegrown sound effects, right? So we're using Audacity and GarageBand to make sounds. The goal, anyway, is to make some really cool sound effects, tie them in. This fantastic web game, which doesn't even require a server, right? No, not it's serverless web game, right? Everything happens in JavaScript and maybe with lambdas. They're doing this, and I think we've only had like 2 meetings. That's all off schedule, unofficial, right? I'm just doing Zoom sessions in the afternoon. I know in the evenings. I think 5 p.m., 6 p.m. Like here, I'm sitting down and I'm just walking them through how to put this web app together. And there's about 4 of them right now. This is HTML, JavaScript, and CSS. Basically, those are the only 3 technologies we're using right now. And they're learning picking up JavaScript on the go. Now, if any of you are interested in being part of it, you are more than welcome. I think they're trying to organize another Zoom session later on, maybe tomorrow. Tomorrow's Friday. Is tomorrow Friday? Yeah, tomorrow's Friday. Maybe, yeah, they're organizing another Zoom session tomorrow night, I think 5 p.m., 6 p.m., something like that. You are more than welcome to join in the Zoom session. I'll tell these people that, I got a couple of 2A students who are also interested in being part of it. And if you do decide to be part for at least the first meeting when you participate in the Zoom session, just participate as audience. And then by the end of the meeting, you'll know what needs to get done. And then maybe you can mock up your own version. You can join the team, and you can also have your own version. You can mix and match features and participate in a team. Everything, everything can happen as it would in a real project. So if you're interested, just do let me know, and I will basically just put you in that group, and you can just come in, and I'll help you all the way through, right? I'll help you all the way through creating the app, launching it, and getting a domain, putting it up there, and even I can help you promote it on Facebook and Instagram, so that people from halfway across the world will come in to your website, play your game, and you get notified. You can look at the log files, say, hey, there are these people from Africa and China and South America and Europe. They're playing this game, right? Right now, you look in the log files, so you can see that. And I can show you how to set up, A/B testing and ad campaigns that which on Facebook and Instagram, so that you can see how to promote your game and what changes you can make and how. Oh, really cool stuff, right? Lots and lots of cool stuff. CS2A is only the beginning. It's only the tip of the iceberg. You'll find out CS2A is the tip of this incredible iceberg, which is made of ice from a snow cone. Okay, if it's just ice, you don't want to eat it, right? This is made of ice from a snow cone, so that you eat the top, and you want to dive in like a polar bear and eat everything. So that's how it's going to be. So if you're interested, reach out to me, and maybe after the class, and I will talk to Christy and Linda and Daniel. Say, hey, Seabait too, I think, right?
So a question.
Yeah.
I think I know something interesting. about CS.
Uh-huh.
So I noticed I used to have this class from Jay. I noticed when you want to make a video game, for example, when let's say someone wins a game, you have to manage it.
Yeah.
So don't just keep repeating it, right?
I'm sorry, I didn't get the last sentence.
You know, so it doesn't just keep repeating, oh, you won, you won. You have to
Oh yeah,
manage.
yeah. That's pretty straightforward to take care of, right?
Yeah, but you know, memory leak is if you don't like clear it, right?
No, what you were talking about is more of an infinite loop or a loop than a memory.
No, I'm not. No, I know that. I'm talking about something else. I'm talking
Right.
about different. So essentially, you know, memory leak usually happens because you know it's part of the code, right?
Yes.
So like, for example, maybe you open a file, maybe like open some kind of instance. You know, I think in Java there's something known as a scanner, and
Right.
at
No,
the end of it you have
anyway,
to close it.
if you haven't programmed in C++, if you've programmed in Java, JavaScript, it's practically impossible to convey the concept of a memory leak, because you cannot have a memory leak due to something that you did in Java, JavaScript, and Python, or any of these other languages. You can only have a memory leak in a language in which you have to personally manage the memory, right? In Java, you never personally manage the memory, right?
Yeah.
Yeah, so you can't have a memory leak, although you can technically have a memory leak in Java, right? Because if you say, well, even though the operating system or the runtime environment is going to manage memory, I don't trust these 20 years of Java super brilliant engineers. I'm going to manage my own memory, right? Suppose you say that and you say, I'm going to allocate this big ass array in memory, and every time I want extra memory, I'll take it from my array and then put it back in my array. Then you're saying, well, I don't trust the operating system, I'm going to manage my own memory. And people actually do that, right? Sometimes I've seen, right? So when and for that you need to I think get to a very, very specific state, and I think you got to be very deep programming, right? Deep programming, in certain situations you find that the operating system, the result of memory management of several decades, right? Several decades of memory management research, even that you find for your very, very specific use case, which is like one in a trillion use case, right? Because you have a 1 in a trillion idea that needs to be done in a very, very specific way. And for that specific way, the tried and trusted memory management does not work, right? And there are situations like that, and I can promise you that you will, in fact, in your programming career, come across 1 or 2 situations like that, okay? So sometime, even if you're programming Java or Python or any other language, you'll come across a situation like that. Then you say,
so memory leak is essentially because you don't manage it by, for example, freeing it up after it's not used, right?
That's exactly it. Yeah. So in Java, you never ask for new memory, right?
Because I noticed that some programs like Firefox, Google Chrome, there was that one time where it had a memory leak, and that's probably the reason why, because they forget to the programmers forget to clear it up when certain things occur.
Right. So what happens?
C++, you have to clear it, don't you?
No, that's the problem.
Oh.
So yeah, in C++, you can get memory, and well, you have to, in the sense your program is not going to die, but it will get fatter every time you ask for new resources. That's why you just keep buying stuff in your home, and you keep buying more and more stuff.
Without clearing it out, right?
Hmm?
Like, for example, eating the food, right?
Yeah, exactly. Yeah, you need an out. You need to get rid of it, unless you make use of it. If you make use of it, that's fine. But if you have useless stuff that you just got because it was useful 10 years ago, right? And what is it? What is it? Rat pack? Oh, is there a term for that? For people that hoard. I think it's a hoarding. Right, so people buy things. It was useful like 10 years ago. Once upon a time I visited someone, and they showed me something, a bill, a till tape from a supermarket, a grocery store, and I said, wow, this is really cool. This is from 10 years ago, till tape. And I said, yeah, 10 years ago. Do you want to see? I got like 50,000 more of those in a box. right? So they store these still tapes, and because they're, I don't know, maybe they have a use for it. Maybe you can make a little notebook for Scratchpad, on the backside of these still tapes. But you can get into that mode in programming, right? So you ask for memory and you use it, and then you say, well, I used that, a million iterations ago. I don't need it anymore, but it's still going to be there just in case I happen to use it again in the future. I'm not gonna, right? It's gonna lay around.
I was laughing.
That happens.
To me, this makes no sense with the code, right?
It makes total sense. Yeah, it makes total sense. Yeah, in C++, it will make total sense. Unfortunately, you guys won't get a chance. You won't.
No, I'm talking about like holding on to it.
Oh, holding on to it. Yeah.
Like holding on to it makes no sense.
Makes no sense. But
Or
we do that,
coding.
right? We do that in real life all the time, right? We do that. We buy things that we buy things just because they're on they're on a sale, right? So we see, just I've seen, in a past life, right? I've seen people that, say, oh, Macy's has got a sale for a sweater, for a Christmas sweater, and we're in the middle of summer, right? We'll go and buy it now. And before, Christmas, there's like 10 other sweaters just like that for half the price, right? And you just hold on to it. You buy things. People do that, and I think it's also very hard, right? It's hard. It's also almost a mathematical trick. Mathematical art to find out the sweet spot, right? To say, well, do I not buy it because I need it 10 years from now? Do I not buy it because I need it 10 days from now? Or do I not buy it because I need it 10 minutes from now, right? Because if you need it 10 minutes from now, you may as well just go and buy it, right? Just go hold on to it. So determining when, I think that only comes from experience. Sometimes you do need to hold on to things. Sometimes you need to let go. And knowing when to hold on and knowing when to let go, I think is something that we'll only learn after a little bit of struggle, painful experience. I think there's a little no pain, no gain. Okay, and it's better to have all your pain in CS2A in class when there's someone watching over and saying, oh, well, I've got my Tylenol here, all right? I've got a bottle of Tylenol. If you're ever in too much pain, I'll give you a Tylenol, but your best chance to have a lot of pain is right here, okay? Do all the bad things you want right here, okay? So I'll make sure you don't die and, make you feel a little bit of pain, but don't do that after later on when you're working for Google or Microsoft and you make this error, and then all of a sudden people find, oh my gosh, my Microsoft Windows just vaporized my screen, right? And all because of Nate, right?
because of memory leak.
Yeah, I don't know, right? So
yeah, that would be pretty scary. Imagine getting blue screen after just a few minutes of working with it because of some memory leak, right?
Yeah, but it's happened, right? How many times in Windows I've had the blue screen of death, even on my Mac, right? I used to get the rainbow wheel of death many times. It doesn't happen.
The kernel panic. That's what you can also. That's I think the Mac equivalent.
Mac, yeah, basically Unix, right? When Unix throws the kernel panic.
And memory leak can definitely be one reason that it can happen on their end.
Yeah, but usually memory leaks don't throw kernel panics. Memory leaks what will happen is your program gets bigger and the system gets slower and slower. And if you're lucky, the system will send an out of memory signal. It's called an OOM signal, right? Bam. Right, and it will kill your process, and everybody else, the whole world will survive, and only you'll die, right? But what happens sometimes, and I discovered that when I was running Docker for questing, right? So on the questing engine, sometimes Docker gets so big that the operating system, especially if I do crazy things, right? So in the beginning, the early days of questing, I ran questing on a very, very small machine, right? I wasn't willing to pay anything. Well, I should have paid more, but I was paying pennies, right? And so I was running my questing engine on a computer that wasn't even as powerful as my phone, right? It was as powerful as one of the old PC XTs, right? It only had like 512 kilobytes of RAM. No, 512 megabytes of RAM. Right, so that's a half a gig of RAM and half a CPU, but still I had 2C quests that required sometimes as much as 256 meg of RAM, And so I said, well, how often are people going to do this? So I'll set the memory settings so that, Docker will grow even bigger than it's supposed to. And when that happens, the operating system will look at it and say, well, that process has gotten too big, I'm going to kill it, right? If it kills it, that's okay. It'll restart and everything will be okay. But what happens is that when it got to that OM size, it breached a certain threshold size beyond which the operating system knew that it had to kill processes to regain leaked memory, but it did not know which process to kill, because when it became big, it overwrote some crucial areas in memory, which told the operating system which process got big. So the operating system at that point became, one of those hand grenades that basically just explode and send shrapnel everywhere. It's called an OM kill bomb, right? So when that happens, every damn thing just kills, and the whole machine could die. And so if you look at the subreddit for questing, you'll see that back in the history, right? Like 3 quarters ago, when I was just playing around with the questing engine, sometimes you'll see these mysterious deaths of the questing engine, and students will come and complain in the middle of the night, right? When I'm sleeping, I get a subreddit post saying, "Oh my gosh, the questing engine is dead," right? Nobody can quest anymore. And then I did some serious debugging over some days, and I found that it was because I allowed Docker to get bigger than it should at the cost of concealing to the operating system what needs to be killed if something got big. And then it started killing everything. It says, "Oh, something is bad, and I'm going to kill everybody around me." Bam, 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 bam. Right? So that you don't want to happen. Yeah. Okay. All right. I took up too much of your time. We've only got like 1 hour left. So you guys should take the screen and remember, okay, make a note if you want to be part of, even as an observer, you can sit in the sidelines and as an audience and watch this game coming together with these 4 people that are working on it. In fact, these 4 people are working on their own versions of the game, sharing ideas, right? So if you want to be like that, that's fine. Or if you don't want to do that and just watch how these people are working together, that's also fine. Just let me know, right? And then I'll say, these people are in here, they're going to watch and maybe participate in future. And then, you can also say, you can, when we have intermediate version of these games, you can play this game and give feedback and say, hey, it'll be cool if you can do this. And that's feedback for them, right? And then they can improve the game so that you can do that too, right?
How should we go about letting you know?
Just send me an email, right? Just send me an email saying, I'd like to be, I also like to participate, right?
Okay.
And I'll let the people know and say, and I'll let you know when the next Zoom session is, so you can just log in. It's usually at 5 p.m. or so, not on Tuesdays and Thursdays. All right, so take it away. Because today is the last class. Is it today? I don't know. I last quarter, did we do data representation in week 2 also? I don't think so. Or maybe we did. I don't know. We can do it next week.
We did.
Yeah. So go ahead, guys. Talk about two's complement. If you don't understand anything, someone else can explain to you. Sign magnitude notation, two's complement, all these things to do with it. Just bounce ideas off each other, and work through examples, and I'll just watch and enjoy.
I actually had a question. So I came late last class, unfortunately, and I just want to make sure that I understand the homework for this week. I do. Should we do the module 0 data representation and 1 second, and mystery quest 1 and the data representation quiz? That's for this week, right?
Yes, you have to finish the data representation quiz and also that preliminary 3-question quiz for this week.
Cool.
And also, Nate, although there is no hard and fast rule for 1 quest per week, it'll be good if you can set yourself the goal that you have to finish homework every week, 1 quest per week.
Cool. Yeah, I'll do that. Thank you.
Cool.
Professor, the due date for the quiz is on 17th. Is that right?
The quizzes?
Actually have till, yeah, I mean the first quiz we have until next week, right?
Data representation, is it?
Yeah, data.
Yeah. It's I think it's next week. Yeah, that's fine.
Okay.
But when you start it, you can't stop the timer.
Yeah, that's right. Was it Susanna who spoke just now?
Yeah, that was me.
All right, yeah, that's right. A lot of people.
But we have like 10 hours, right? I think there's 10 hours for that quiz, right?
No.
I think we're supposed to have one.
Yeah, I wouldn't take a quiz that takes 10 hours. It's how long is it? 1 or 2 hours? I think it's 1 hour, I think. Or is it 45 minutes? I don't know. I've forgotten.
I thought it's 600 minutes. I thought it's 600
Yeah,
minutes.
I think it is 600 minutes.
I could be
like-
wrong.
Holy cow. All right. Okay, thank you. All right,
Yeah,
I'm
I
going to
saw
change it
that.
now.
I was like,
Yeah.
what the?
All right, I'm going to change it right now. Maybe I think I it was a mistake. And I think it was a
Oh
mistake.
no!
No, it was 1 hour is plenty. Because if I give you a
Sorry,
10
guys.
hours- No.
It's
Don't
all
worry.
right.
If you need more time, I can always give you more time, right? But I think with 10 hours, it ends up confusing more people, right? I think you finish it in 1 hour, and then you end up, many people are actually just worried. I think, oh my gosh, did I do things right?
Can you make it 2 hours?
No, I think it should be 1 hour. I think you'll find it more than enough.
Oh no!
It is pretty easy, to be honest.
It's very easy, yeah. If you need more time, just let me know. But I think 1 hour is more than enough. Yeah, okay, so I changed it to 1 hour now. Okay, all right. What else? So go ahead and talk about something for data representation, and one of you should ask a question, another one should help out, and so on and so forth. Let's get that going, because this is remember, right? This is being recorded, and your discussion between yourselves is going to help future students, right? So someone else next quarter is going to play your video and look at it, and someone is going to bookmark it, saying at 17. What time is it now? All right, at 57 minutes 27 seconds. Elizabeth and Nate were talking about two's complement. Okay, so then someone will click on it. Someone later on who doesn't understand two's complement will click on it and look at the discussion that you two have, and say, hey, all right, those people had exactly the same issue as I did, and that'll be cool, right? So just carry on a conversation. And this is also, participation. So you can do this, and it also substitutes in a way for online participation, right? At the end of the quarter, when I run my algorithm and pull out all the names that match that pattern, right? That pattern that I posted for first name underscore and then alphanumeric, and that I'll pull it out and I calculate the participation scores, and I see, Chad, he never ever posted on Reddit, but he was so active in class, right? He was so that basically makes up for everything. You don't have to post it all, right? You don't have to post it all, but your class participation made up for it. So that gives me a chance to do that, right? At the end of the quarter. And again, remember this, I am only looking for excuses to give you points, okay? So I want all of you to pass 2A. I won't say this for 2B and 2C, right? I don't want people to pass my 2B and 2C who are not good, right? So if you're not really super duper good, I don't want you to get a B. I don't want you to get an A in my B or C, right? In 2B or 2C, I want only the really good people to get A's. Not good. I don't believe that people are good and bad. I only want people that are really interested in computer science and C++ to get A's in B and C, right? But in CS2A, you can make my day by making the entire class get an A. Every one of you should get an A in CS2A, which means that every one of you should want something that is so nice about C++. And so when it comes time to week 12, what I'm looking for really is, how can I give points to these people, right? So I'm looking for excuses, and you have to give me excuses. And many times, and you may think that is incredible, you may not even believe it, right? But I can assure you that it is 100% true. Every single quarter, I come across students for whom I want to give points, but they have not given me a single reason, right? I look at every single thing. I look at every single video. I look at every single post in Reddit and everything. I want to give them points, but I cannot hang that point on any single hook, right? And as a consequence of which, they end up with a C when I think, well, you know what? I wish they had ended up with a B or an A, but I can't do that, right? So, no, I can't keep it at 600, Kyle. You'll be bored, right? And lots of people will, finish it and then they'll just end up agonizing for a long time, right? Let it be 60 and you tell me afterwards, okay? So tell me 2 weeks from now, you guys tell me 2 weeks from now, after the quiz is closed, you tell me what is a good time for that quiz. And I bet it'll be 2. You take a poll on Reddit and say, take a poll on Reddit and say optimal time for quiz for the data representation quiz, 1 hour, 2 hours, 10 hours, right? Take a vote and see how many votes each of these get. I bet that 60 minutes will get the most votes, right? After 2 weeks, don't do it now. All right, go ahead. Okay, so someone come up with a problem that something you're struggling to understand with two's complement with data representational issues, right? Floating point numbers. If you're struggling with floating point numbers, talk about floating point numbers. And when you're talking about floating point numbers, maybe two's complement gets confusing, right? So maybe someone talk about two's complement first. Maybe someone who doesn't understand two's complement, ask a question about two's complement, and maybe someone else who understands two's complement can jump in and help them out. How many of you have iPads, by the way? iPad or some tablet, or a phone on which you can have run Zoom, right? If you can run Zoom on a secondary device, like Elizabeth and I have. So Elizabeth and I both of us have got 2 sessions running, right? I've got this on the other computer and I have a phone, this iPad, so I can use that as a whiteboard, right? So if you have a tablet in addition to your computer, get your tablet, run Zoom on it, join the meeting. And so if you have a data representation thing that you want to clarify with a fellow student, you can just share your tablet and say, well, this number I'm trying to convert, right? From positive to negative using two's complement. How do I do that? You write the number out and your screen is shared, someone else can chime in, right? So I think that'll be a really cool idea, way to do it. Or else you can also share your screen and type it in, right? In a notepad window, type it in 1100. You can verbally say, I'm trying to convert this number in hexadecimal, right? And someone else can do it. So that's all fun, right? You'll find it's a great deal of fun to do these things, right? You have to get into the hang of it, right? Get used to doing it this way and you'll have a great deal of fun.
I'm curious, I'm just jumping in to go for it. I'm curious if anybody's found any other helpful videos that explain stuff, because I found myself struggling through the reading, but once I watched, I just did it in order of how it was presented. So once I got to the videos, I was like, well, why didn't I just start here? Because I found that extremely helpful, like if I would have done it in reverse. But I'm wondering
which
if
videos are you talking about? Yeah, I think some of your classes.
Oh, like the couple of it was only like a couple of minutes long, things that like explain binary and like how to translate it quickly and things like that.
Oh yeah.
And then I feel like if I would have started with that and then gone to the reading, but I was wondering if anybody had come across any other helpful videos that helped them grasp the concepts in the reading.
And please share in the Reddit, right? Because other people like Elizabeth, they would also, I mean, Elizabeth is mentioning it, but I'm pretty sure a lot of people felt that way but didn't bring it up here. Yeah, Kyle posted the video. Kyle DeMello. Kyle, are you here?
Yeah. Hi.
Kyle posted a video
On Reddit.
On Reddit. Yeah. For binary. Yeah, that's the one you're referring to. But there's other videos, right? There's other videos other people have posted. It's just getting hard to search on the Reddit, I think. Maybe I should just create a flare. Maybe I should create a flare for video. And
that'd be great.
Yeah. But someone will have to go and tag all the past posts with videos. It was last quarter also. People posted videos, sometimes 3 or 4, right? So there were videos on Khan Academy, right? So you can find videos. Anyway, I'll mention it, okay? And maybe you can share it in the Reddit later. But these are places where people have found useful videos. Khan Academy, right? Is someone remembering these things? So right, and so that we don't forget this Khan Academy, and what else? There's a course at Harvard. There's a course at Harvard, and which is also free and public, just like we're doing, right? So, and I think David Marlin, right? Is it David Marlin? He's the lecturer who teaches this course, CS50. The course is CS50. Yeah. CS50 at Harvard. I think it's David Marlin. He teaches it, and that's also video. That's recorded and posted on YouTube. All of. So in fact, you can see, just like us, you can go through all of the lectures for CS50, starting at first one. So That's there. Pretty sure Stanford also has these lectures and posted. I'm pretty sure I saw one coming from Cal Poly, maybe, I think Cal Poly. Everybody, yeah, many people posted. No, what is this most recent one that got posted? I think it's UCS. I don't know. No. Santa Clara University, is it? Something like that. One of these places. Lots of videos. Please post. Adam, can you post these in someone collect these and post it in the Reddit?
Sure, I'll do it.
Okay, and in fact, you can post the one, and then as and when other people post, they can either post in the comments or send it to you, and you can edit your post so that we have a list. And then what we can do, we'll come up with some idea, right?
Yeah, all right, no problem.
We'll do a flare or pin it to the top or something like that.
Yeah, I think if
question?
Reddit's going to be a long-term thing, you should. Oh, sorry.
I have a question. So
Yeah.
I got accommodations there. So can you extend my time on that first quiz to 1 hour 30 minutes because 1.5x?
Oh yeah, sure. Yeah,
Because-
no worries. Who is this? Yeah, by the way, you in fact, do you want me to do it right away? Because this quiz is really only a 30-minute quiz. I can, you know what I can do is I'll make it 2 hours. I'll just make it 2 hours for everybody.
Cool. Good to know.
Yeah. Okay.
Yeah, and also one question. So I think I'm going to try and watch some videos on how these numbers work as well. That will help me understand.
Yeah. But wait until Adam posts the links, because I'm pretty sure. In fact, what you can do.
Are there like videos I can look at as well?
Yeah.
That
Videos we can look at.
Can you speak, because some people did suggest, where can you find these people that suggested videos to watch?
Oh, everything is going to be on Reddit.
I think he's talking about the past students, right, Chad?
Oh yeah.
Yeah.
You know, for the data representation, so you know how each works.
Yeah, how do we find those old videos?
Okay, all right. I know one way in which you can just narrow down your search. I don't know if you can go exactly to the videos, but I think all of the videos got posted under the tips and tricks flare. It's not under quest flare for sure. Okay, it's not going to be under duck or crow or something like that. It'll be under the tips or tricks flare. So hopefully you'll only have like 30 or 40 total posts under that flare, and you can easily narrow down your videos there.
Is there a link to tips and tricks?
Yeah, you just click on the tips and tricks flare button, and it'll show you only tips and tricks. So on Reddit, on the subreddit, if you go to the subreddit and you see those capsules, the capsules that say tips and tricks, crows, building blocks. Oh, it's probably under building blocks. It's under building blocks, not tips and tricks. So if you go to the subreddit right now, you'll see a whole lot of posts, and then on the right side, you'll see these blue colored capsules. Not all the way to the right, you'll see these capsules by the title of the post. Do you see them or not?
Yeah, building blocks, yeah.
Yeah. So if you just click on the capsule itself, building blocks, then you'll only see building blocks. Oh wow, I think there's about 60 or 70 of those now. Oh yeah, there you go. I just scrolled through it and I saw, please watch this important video, 7 upvotes, right? Please watch it, and 7 upvotes here. Wow, especially the first 5 minutes at 9:30. Oh, that's something I posted, right? No, that's something that I posted. No, I thought it was something that's a student posted. Hang on, but this is something I posted. I'll share it here anyway, but I'm pretty sure I saw a whole bunch of student videos right here. Simple code calculator introduction. Yeah, you can find out. I think there's a lot of stuff here with videos. Yeah. Oh, there's also this game. It's a really cool game that Google came out with. I think that will also be nice for you to play here. Yeah, you share this also on Reddit. Share all of these on Reddit. Yeah. Well, anyway, search the flare. You'll find a whole lot of stuff.
And
Yeah.
if I can jump in, I don't normally do well with videos. Khan Academy works fantastic for me if I'm confused, but normally I actually go and find an article or something like that because I do better
Yeah.
reading about my stuff. So for instance, like with Two's Complement was confusing. And so I kind of just typed into Google Two's Complement and tried to find an article that explained it best for me. I think honestly, I think for me, Wikipedia worked best for me for Two's Complement, but obviously not always going to be the case. I always have to find something.
So
But
can you also share, hey, Peter, can you also share links to articles then? It doesn't have to be just videos. If you
yeah,
find,
certainly.
yeah, absolutely. So you should share that too. Just compliment, if you think about it, Peter already knows this, of course, but is the concept is really simple, and we go over this every single quarter. Anytime in this just complement binary, right? If you find it confusing, just forget that you're in binary land. Just forget and imagine that you are basically in decimal land, just like here, right? And ask yourself, what would you do if you were? How would you represent a negative number in base 10 if you didn't have the dash symbol, right? Because you write -1 by saying a -1. But if you didn't have a dash, if you could only write the digits, how would you write negative? How can you communicate negative numbers, right? And so that if you think about two's complement from that perspective, it'll make total sense, because what you would end up doing is in tens complement, you would essentially find out what is called the tens complement, right? And in fact, the recording, the CS2A recording of the first couple of lectures from last quarter, we worked through exactly examples like this in tens complement, right? We do tens complement and then talk about two's complement, and it makes total sense, right? So please, look at that. For those of you who don't understand two's complement, do look at that video, right? Before you look at some other videos or articles. Look at the video from last quarter about two's complement, and hopefully someone will also put a time comment with the time mark on it saying
What's two's complement? What's two's complement?
So two's complement is a way in which we cleverly represent negative numbers in binary, because in binary, if you think about binary, you only have symbols for 2 digits, right? You have a 1 symbol and a 0 symbol. You don't have symbols for anything else. You don't have a symbol for a point, so you can't say 1.5 in binary. Can you? Because you don't have a point, right? And you can't say -5 in binary either, because you don't have a dash. You only have 2 states, because these 2 states are in a computer are essentially is current flowing through a wire, or is a wire dead, right? So is a socket live or dead? How do you find out if current is flowing through a cable or not? One way is to basically just take your shoes off and go and touch the wire, and then you'll find out immediately if the wire is live or not. Yeah. So, but that's really how a computer stores information. It basically says, my ones are going to be current on, right? The current is flowing, and my zeros are no current flowing. So if I basically graph it, if I say from 0 to 1 second, current is flowing. From 1 to 2 seconds, no current, 0, right? So if I graph it like that over time, my seconds, the x-axis is my time axis, right? 0, 1, 2, 3, those are seconds, right? And I graph the current density. I go, 1, 0, 0, 0, 0, no current. 1 again, 1, 1, 1, 1, 1, 1. Okay, again, 0. So this way, if I send the current down a wire to someone else who is able to measure the current, they can now, with a notebook and a pencil, they can observe the current and write down, okay, Anand sent a 1, 0, 0, 1, 1, 1, 1, 1, 0, 0, 0, and so on, right? That's possible, isn't it?
Yeah, you can do those string. It's like Legos, right?
Yeah, exactly.
That's what that ones and zeros are like. That's what I kind of figured, that's how numbers are stored in computers.
Yeah, exactly. That's exactly how numbers are stored.
But I also know you can find YouTube videos on how negative numbers are stored.
Negative numbers, yeah, exactly, yeah. But before you watch those videos, try and come up with your own way, because I think the best way to understand anything at all, anything, not just CS, right? Anything at all, is to try and do it yourself first.
And try and make a point, right? For yourself.
Yeah, exactly.
I think, but I think negative numbers might be stored a little differently than positive numbers.
Yeah, I think
Well,
so. Yeah.
isn't it just reallocating memory in like that's like the very basic approach to it, right? It's reallocating that limited memory that you have in a different way.
Um, I wouldn't call it reallocating because allocating has a different connotation in a language like C++.
Okay.
It's all about encoding
Encoding.
an idea into a form that can be stored electronically. The revolution of like the computer age really started with the transistor, because that component allows us to sort of control and manipulate electrons in a logical flow. They can act as switches and as amplifiers that then go into more grander designs and into stuff like that we have today, where like our gadgets are like feeding are receiving input at like millions of bits, billions of bits a second. um, and that's really just because we figured out a really cool way to encode that analog signal into a digital signal. And when you think about it, the quickest way to do that is just an on and an off. And that's why we have this binary system. We have base 2, and if you think of like all of the zeros and ones as positions, you start from the 0th position to the first to the second position, third position, and in that you have this amazing uh, 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 this huge space to just encode different protocols, different ways of representing the real world, and that's really what it all comes down to. When you really look at the architecture and like the hardware in these computers, it's all smoke and mirrors. It's all like very clever deception to make it feel real, and whenever I think about like how much the fidelity of like video has come since the 90s, the 80s, like when you look at it, it's like, oh yeah, when people see a good TV, they say, oh, it's so lifelike, it feels like it's popping up, but it's all deception on that level of zeros and ones.
Hey, Aaron. You know what? So on an iPhone, the resolution is really high, right? So you can't see the individual dots usually. I found a way. So you take a drop of water and put it here on the surface, and with a picture underneath. Now, so if you look at the edge, if the corner when it's tapering off, in one place you can actually see the individual pixels, even
because
at
the light refracts, right? When
yeah,
the light refracts, and it changes the angle, it magnifies the space between them.
But it used to be easier with older phones, even like 5 years ago, right? Now it's getting harder and harder.
You would just tilt it. And you'd see the little like pools of like the crystal before we had like OLED and all like this. The crystal back with a backlight LED. It was so easy to see those.
Yeah, now I'm pretty sure with all these newer displays coming in, was more tightly packed. You got to really look at it with a microscope before you can see the individual.
So I was gonna say I've built up a lot of videos, a lot of STEM videos, just because it's what I consume on my off time anyway. So I've built up quite a few that are really cool, more in the space of like electrical engineering, that I think would help your intuitive understanding of how we get from electricity to what we see on the screen, which seems like freaking magic.
Oh, that'd be amazing. Do you have a link to that?
Yeah.
Oh, sorry, I didn't mean to.
Yes, I do have a link. I'll post it on the Reddit. I'll also post it on the Discord I just joined.
Oh, that was you. Okay.
Actually, add it. So that you should add it to Adam's. Adam's building a list. And I saw that, hey, Adam, the list right now is a little hard to navigate because it's just a list of, well, of course you did it in an instant, right? It's just a list of things. It'll be nice if you indent or bullet these things so we know if these are separate. And also if you can add within parentheses, a small, one or two, a few words to say what they are, so that people can pick and choose which one they click on.
Sure.
Yeah, okay, that's pretty cool. And Aaron, if you can send your link to Adam, he can put it there too.
So I think he's
Yeah, you
right
can send me
on.
on Discord.
Oh, can I tell you something real quick?
Yeah, we're all hearing.
I think I know something. I think a lot of the digital video stuff is technically illusion. I agree with that, right? It's really just so many pixels, right? Which makes it
Yeah,
look real.
yeah, it's what our
Those
mind
tiny,
tells us.
tiny LEDs that we can now manufacture on like such a high density and such large scale because of like
It's really
femtosecond
cool.
freaking
really
pulse
cool.
lasers that we have. So it's like a testament to like just how like much innovation like the computer age has brought, and like and when you think about it, it's all on off on off. You can encode a signal that way. You can make like Morse code is on off. Yeah, so it's
I know
sort of the
something.
same. Yeah, it's sort of the same idea, but
So
on the scale
technically,
of like how do you hold electrons in a state? How do you remember a state and stuff like that?
so technically, my screen is technically made off of so many different lights, right? Like billions of different lights, if I'm correct. And it's technically, they can have all sorts of different colors, all that, right?
RGB.
Red, green, blue.
Yeah.
Because when you think of the color spectrum, yeah, you have blue, which is really high
Primary
energy.
colors.
Yeah, I think.
Yeah, you have,
Well,
you have
not
blue,
yellow.
which
And you
is
create,
really high energy on like the.
Do you create like an illusion so that way, the colors look like they're mixing together, and that's how I get all these different colors?
I have a chart. Okay, let me send
Well,
you
that's
this
also
chart,
like
which is the visual spectrum.
when you squint your eyes at a blurry picture, you can tell what it is better. I mean, that's kind of leaning into the same idea that you're trying to figure out there.
What the incredible thing about these things is that no matter how sophisticated our traditional computing gets, right? Even thinking about 10 or 15, 20,000 years into the future, if it's a finite machine processing discrete data in bits and bytes, it's still countable and it's discrete. But when I see a picture on the screen, when I see a picture of Aaron or Robert, or when I see it, I don't see something that's continuous. I see something continuous. I don't see something discrete. I see some. So the incredible thing is that, just like Aaron said, what the system presents to us is basically just a set of discrete dots with gaps between them, but we don't see the gaps at all. So where is the matter between the dots? That matter comes from our own head. So the illusion of continuity, which really is supplied by us, we supply the illusion to make what the computer gives us continuous, because what it gives us only fills the lattice points and not the continuum. The continuum needs to be filled, and that we do. That's incredible, isn't it? Because otherwise, even a newspaper, you can use a lens and go deep, and you only see dots instead of the letters. I don't know if you guys see newspapers, ancient history.
Yeah.
I think I've seen a cool video. Can I share it with you on Reddit one day? It's about inside. It's interesting. It's what happens if you look closely on an LCD TV.
Oh, even the new ones, in the modern ones?
I mean, the red, green, blue stuff.
Yeah. But do the new ones also have that effect? Because I tried to do that. Yeah, someone I knew had they bought a new LG OLED, LG OLED or something like that.
But I mean, I was actually from those times, the LCD times, which kind of did that.
Oh, I see. It only happens with LCD, maybe.
But yeah, I'm looking at a video, see if I can share it with you. If it's one
totally
that's
believe you.
up close,
I totally believe you. Because even until 5 years ago, TVs, you can. If you go to Costco, they have the latest and greatest right at the front. Where these are big screens with extremely high resolution. But if you go to the back, where they have the cheaper TVs, you can actually go up close to them and you see the dots. And but it doesn't happen anymore. I think the TVs are getting better and better.
I actually have a video showing how my older TVs work.
Yeah, post that too.
I posted on Zoom.
I see, but post it in the Reddit with some commentary. So
very interesting because the digital screens are just like a bunch of lights, right? And
Yeah.
Or technically, and I think you're creating that illusion. That's what makes it look so real, right?
Yeah.
With
Yeah.
so many
incredible.
lights.
So
Yeah.
these are LEDs. This is a particular form factor, but essentially these are the guys that are in your screen. Let me get a blue and a red. I believe I have a blue and a red. And these are just, easy to breadboard components, but the ones that they have, the ones that they're producing on a mass scale are like, 3 orders of magnitude smaller than this. Like this is, or like even maybe higher. But like these are essentially what's on your screen, tiny bits of them. And when you pass a current through them, they turn on. And that's how LEDs work. And mostly the LEDs that you see right now, and you probably have LED bulbs in your room. You don't know, but it's actually flashing at a certain rate, but it doesn't look like it to you because it takes advantage excuse me, takes advantage of the fact that it takes some time for the signal to drain in our system too. So to us it looks continuous, but it's not. Take
Hey,
your
Aaron,
phone.
A good way to break that down in your brain is to
That's
do like if you have
awesome.
an iPhone to like do the slow-mo video.
It's taking a
And
lot of pictures. It's
yeah,
taking a lot of
if you watch the slow-mo video, you're like, oh, I see the flicker now. Like it is just an
Yes.
illusion. Yeah.
Are
Or
talking
if you
about
take a
the
video in
new
general.
OLED? Are talking about the OLED?
Aaron,
We're talking
No,
about all of
just
it.
look at your LED.
did
If you
not,
have LED lights in your room, take a look at the bulb brick. I have some broken bulbs.
hey, Aaron, I actually didn't know that. So so you're saying the LEDs that we use operate on straight alternating current, so that 50% of the cycles
Oh
they
no,
don't glow?
Oh, they sometimes do, but like most LEDs right now they have a regulator at the
They do have a converter, a DC.
yeah,
So
they have
they
a
operate
converter.
on
They have a
DC.
converter, yeah.
Oh,
To
but you're saying the DC waveform is not continuous. There's a little blip on.
I'm talking about pulse width modulation. So
Oh,
like
I see. I see.
yeah. So to us, to our eyes, the LED light is continuous. It's almost like it's shining all the time. But if you actually take a closer look, and if you actually analyze the circuitry behind these, they're using some alternating current to turn the gate on and off so that the light flickers. But to our eyes,
Why
it
would
doesn't
they?
seem.
Why would they need
So
to? Why do they need to do anything more than just convert from AC to DC?
because these guys do not like heat, and so if you can control, if you can decrease the amount of time that they're on at and decrease the continuous
That's
time that they're
okay,
on,
I got it.
you
I got it.
you
Okay.
extend their life.
That's
So
actually really
if you
cool.
think
I got it now.
if you think about it, PW. So there's
I
two
got, no, I
ways
got it.
to limit
Totally, I
the
understand.
light.
Yeah.
You can like turn it on or off. Yeah.
So what Aaron just said is that there's, and correct me if I'm wrong, Aaron is saying there is no reason per se for them to flicker, but we inject the flickering to make sure that they're not on continuously.
Heat control.
Heat control. Yeah.
Because it's such a small system, you can't get a powerful enough heat sink going to just get something for your CPU and jimmy rig it onto an Adreno setup.
Hey, I didn't know that. I didn't know that. I thought they were on
I
continuously.
have a question. Does that apply to LED TVs as well? The flickering effect?
I mean, they have their own refresh rate, so that's really what you want in a TV. It's not so much because the TV isn't continuously putting out the same image. It wouldn't make sense.
Hey, what if I had?
You wouldn't PWM it that way.
What if I had a white screen on a TV and I took off?
If you had a what?
White screen. So like Zoom, right? Like a Chrome window. If I displayed a Chrome window, which is completely white on my TV, and then I took off, right? So it's not doing this automatic refresh. It's not doing. You said we don't need the on off for the TV because the picture's flickering anyway.
You're right. Maybe there is. I get your point because that would kill the LEDs. The white light.
I don't know. I think you're right. Yeah. Because I know, yeah.
Or maybe they enforce a refresh, even though it's a static image. They enforce a refresh
Maybe.
so
I
that
think
it
that's
doesn't
what you're
turn on
talking
all the
about
time.
even,
Newer
is they have a
monitors
constant
don't
refresh.
usually have screen burn in anymore, so I would assume that there's some type of refresh built in to make that avoidable.
Yeah.
How it works, I don't know. I'm just going off a
And
theory.
I'm sure it creates some optical illusion, right?
Oh, I didn't know. So the new TVs don't have any screen burn?
No.
Most of them
They
don't.
minimize
No.
it, yeah.
Only
Yeah,
OLED.
I don't know
Get an
why
old
OLED.
CRT.
Organic.
Oh, CRT.
Yeah,
Yeah,
I
it
know
really
something
doesn't
about
happen for
CRT.
like the
If you slow
lifetime
them
of
down,
when you have it anymore.
Or maybe it's a degradation in the quality of the LCD, because I know I had an LCD TV for a long time. We had it in our home, and I'm pretty sure that towards the end of the life of the TV, you could still discern pictures, and there was definitely some burn, something that looked like a burn. Maybe those LEDs weren't lighting up as enough, or I don't know.
Oh, well, it's like any type of hardware that you use heavily, it's going to get some wear and tear. You have a wrench and, you know, you're not eventually not going to be able to grasp as well anymore. You have to get a new one. So like there's going to be wear and tear, and over
What would
time, yeah.
happen inside of an LED? Does the thing get whatever the germanium or something? Does it get oxidized over time, or I don't know. I don't know. But you're right. Yeah, I don't know how it happens though. Inside, how does an LED get old?
so I know something
yeah,
about CRT TV.
Uh-huh.
If you slow it down, you know the whole thing's really optical illusion.
So yeah, CRT I've seen it in CRT.
I've seen it where I try to record it and they can't really see it.
Yeah.
Because it's the optical illusion.
And in fact, if you take a video of a CRT TV, you can even see in the video frames, because there's a mismatch between the.
Yeah, you see the scan lines.
Yeah, you can see the scan because.
And I noticed that if you slow down LCD TV, you can kind of see it scan.
Oh, I see.
It has to be super slow to see it scan.
Yeah, it depends on the frame rate of what you're recording with.
Yeah, I mean, it has to be so low, right? You have to have a special camera, I think, and you have to zoom it in, and you can actually.
Now we can do it. I'm very sure with slow motion capture on iPhones.
But I think I've heard that. I mean, I wonder if my new monitor technically flickers all time. You just can't see it.
It does. Well, and correct me if I'm wrong, if I'm completely out of ballpark, but when you take a video of like a monitor or like of a TV, it seems to it flickers. Like when you see a video of a screen, unless the video like quality is like extremely well done,
that's what CAD
you see the flicker, you'll see it refreshing constantly.
Yeah,
because I don't see it refresh. I tried taking a video of my computer monitor, my modern one. It does not do that flicker thing.
Oh, it happens to me. But I think the reason is because of the mismatch between the capture rate and then the display rate. Because if that's if the refresh rate is 25 hertz, and then my phone is capturing at, I don't know, some prime number, co-prime number rate, I'm pretty sure there's going to be some. Oh no, not co-prime. It's some rate it'll find.
Well, now we just need wireless VSync on everything, and then we won't have to see any flicker, and we can live happily in the Matrix, you guys.
I'm pretty sure that in 5 years we won't have TVs like this. TVs will just be built into our phone, our eyeglasses or contact lenses, right? And so we won't have these traditional looking TVs anymore. You have a TV in your pocket and you can put it in your eyes. All right, so it looks like
we're done.
It's time, but we didn't actually discuss any data representation stuff. What I would like, and the first week really is introduction and getting to know each other, which I think we've done a good job of so far.
I still did a good job explaining computer stuff, right, as well.
Sorry, what do you need to do?
Here, I'll just type it.
Yeah, well, anyway, so this is what I'd like if we can do next time. Next class on Tuesday, let's start with some data representation problems already. From the word go, someone picks up a data representation problem, either two's complement or all the way from representation of data representation, number of possible combination of bits within a byte and so on, all the way hexadecimal and so on, to two's complement, floating point representation, big problems that you don't understand or having a lot of trouble. We need to have at least 10 problems, okay? 10 people, one problem each maybe, or 10 problems that you are going to be working on in class, from the beginning. And then you're going to be chiming in, just like now, you're having a conversation about TVs, you're going to be having a conversation about these numbers now, right? And procedures to manipulate these numbers. You're going to be doing that, and I'll just be sitting here and watching what's going on. I'll be happy to do that.
I actually do know hex pretty well.
Hexadecimal, yeah, okay. All right, great. So
it's base 16, right?
Oh, no. F character is not hexadecimal. F stands for floating point.
No, but you do know that hex goes to F, then it goes to, right?
Oh, yeah.
It's technically base 10. I mean, base 16.
Yeah.
Right?
So this could in fact be a hexadecimal floating point number. 0.001F. That could be a hexadecimal number, a hexadecimal fractional number. And in fact, the value of that number, which Fear, I don't know how you pronounce your name, Fear, the one that he typed in.
I'll see you later.
Yes.
Yeah. Is 1/16 to the 116 squared, 1/16 to the cubed, 1/16 to the 3 plus 15/16 to the 4. That's the value of that number. You can calculate that, right? So, but we can do all that. We can do all that in class, next class. And so when you get back with some interesting problems, okay? Get back with some interesting problems so that we can minimize our discussion about non-technical stuff and then slowly start maximizing our discussion about stuff that we are going to do in class, okay? Programming and data representation, that kind of stuff. So can you guys do a little bit of homework to come up with some interesting problems to start working on in class starting next week? So on Tuesday next week, let's still continue on data representation. And on Thursday, I'm pretty confident we can cover branching and looping and stuff like that. It's all pretty, once we start coding, we'll be getting into coding big way. Yeah?
Yeah.
Awesome.
Thanks.
Yeah, I actually started by Hello World and finished it.
Hey, cool. All right.
So I'm already into C++ now.
You're into C++. Now all you're waiting for is world to come back and say hello back. Hello, right? Okay.
Yeah, because I think some of my Python skills transferred.
Awesome. That's fantastic. Yeah.
Everyone's coding till the computer says hello back.
So I'll see you later. I'll see you next week and hope to come up with a challenge, and maybe I'll try and figure out some stuff myself with numbers.
Fantastic. Thank you so much, Chad, and all of you guys. Elizabeth, everybody, right? Thank you so much. Come back, and by the time you're done with the C++ series, I will promise you that the world will come back and say hello back. Okay. Cool. In fact, those exact 2 words you will notice. Write down in your notebook. Hello back. Hello back. Okay. You will hear those words from the computer. Right now, my CS2C students are in fact hearing them. Well, not my previous quarter CS2C students are in fact right now hearing those words, right? And you will also hear those words. All right, thank you so much for today, and we will recongregate on Tuesday, unless any of you are interested in participating in this web app development thing. Then you just send me an email. We'll get back in Zoom tomorrow maybe. I think they're organizing a Zoom session tomorrow night, and we'll Zoom again tomorrow night for that. Okay.
Cool. Thank you.
Thank you. All right. See you guys.
Thanks.
Bye.
Thank you, Anand.
Thank you.
Thank you. Bye.
Bye.
Thanks, everyone.